Hello everyone. So welcome to another problem on integer programming, and I'm doing a playlist on integer programming problems. So I'll keep adding more and more problems to that playlist as we move along. And this is a problem. So you can just try yourself addressing this particular problem. You can pause the screen, look at the question, and try to solve it yourself. Later you can compare your solutions with my solutions. So let me get started. So the question is about Terraco Motor Company produced lightweight all-terrain vehicle code named J99 Terra whatever for military. The company is now planning to sell Terra to public. It has five plants that manufacture the vehicle and four regional distribution centers. So okay, so whenever there is a plant, manufacturing plant and regional distribution centers or warehouses, that kind of thing, then it is like a transportation related kind of problem. Company is unsure of public demand for the Terra, so it is considering reducing its fixed operating cost by closing one or more plants. This is important. See, the objective is not to run all the five plants. Okay, so there are one, two, three, four, five plants. Maybe only two plants are running, or maybe four plants are running. One or two plants, uh, one or more plants here it is saying, uh, will will have to be closed. Okay, so here is where integer programming comes into picture with binary variables. That is important again. Okay, so let's continue. Uh, Considering its fixed operating cost by closing one or more plants, even though it would incur an increase in the transportation cost. The relevant costs for problem are provided in the following table. Okay, so let's look at the table. So, okay, obviously we have one, two, three, four, five plants, A, B, C, D, four warehouses. Okay, here it is there. So, from a particular plant to particular warehouse, what is the transportation cost in thousands of dollars to the warehouse? So, for example, from plant number three to warehouse number B, uh, the cost is $71,000 for one transport between 3 to B. Okay, so that is the thing. Similarly, all others. Now, annual production capacity. So each plant, one, two, three, four, five plants have the different capacity productions, and then annual fixed operating costs also there. So irrespective of how many vehicles you are manufacturing, the fixed cost is always present. Okay, so here it is $2.1 million, $850,000, 1.8 million, and so on like this. Right away, you can see the here you can see the company is unsure of demand and considering fixed operating cost by closing one or more plant. So obviously, if I want to close, I will go and close the plant number one because 2.1 million is almost more than highest cost. Okay, so 2.15. So the idea may be to close plant one, but then sometimes what happens, the transportation cost may be less compared to the other. So in with respect to transportation cost, maybe this is justified, and we may have to close the plant number three, which is 1.8 million, which is the next highest. So, and I am hoping, in no case, see, look at it, right away I can see here 18 is less, 46 okay, less than 71, 7 is very less, 35 also reasonably less. So looks like plant number 2 will definitely be operating because and its production capacity also more, and this fixed cost is less. So something like we can just tell, just by looking at the numbers we can tell some answers, but then let the computer solve it and give the proper answer. So let's wait for that. Meanwhile, annual demand also given. At warehouse A, demand is more, not more, it is only 6,000, whereas warehouse B more demand, and so on. So formulate and solve integer programming model for this problem to assist the company in determining which plant should remain open and which should be closed, and the number of vehicles that should be shipped from each plant to warehouse to minimize the total cost. Okay. So number of vehicles we have to find out, and which plant. Now again, obviously vehicles also, since we are discussing integer programming problems, vehicles cannot be like a fraction. Vehicles needs to be a round number. Now here one more point you can see, the transportation cost are per thousand vehicles shipped. So shipping of the vehicle is in the bunch of thousands. For example, the cost of shipping 1,000 vehicles from plant 1 to warehouse C is 32,000. So in that sense, the here the the vehicles are being shipped in bunches of thousand vehicles. So I think let us denote that as this thing. So let's start writing the formulation now. Okay. So here you can see, um, see from plant to warehouse. Okay. So X I J, okay, is number of thousands of vehicles from plant I to warehouse J. So this is how I am defining, and here the keyword is number of thousands. This is in number of thousands, and it is a integer. So now, for example, example if so, I'll say x4b is equal to 7. Okay, if x4b equal to 7 means from plant 4 to warehouse B, we will transport 7,000 vehicles. So here you cannot have like 7,100 vehicles, something like that. The fraction is not allowed. So whatever we are saying, it's in the number of thousands. So finally our integer answers will be coming. Okay, so this is about the definition. Now let us look at the formulation, right? What is our objective? So here look in the last sentence again. Formulate and solve integer programming model to assist the company in determining which plant should remain open, which should be closed, and the number of vehicles should be this, etc., etc. Minimize the total cost. Okay, so that is the thing. Okay, what is the total cost? The total cost will be transportation cost plus annual fixed operating cost. Okay, so transportation cost plus fixed cost. Okay, so for this, let us now introduce binary variables. Okay, so here I will write let y1, y2, y3, y4, y5 denote binary variables for transportation cost. Okay. So these are the 5 variables which denote binary variables for transportation cost. Okay. So that means if I'm sorry, not for transportation cost, this will be for operation of plant. Operation of plant. That means, so example, if y1 equal to 1, then operate plant 1. If y1 equal to 0, then close plant 1. So this is the meaning of this operating and closing. Okay. So now what will be the fixed cost? So fixed cost will be, so here you see there is a annual fixed operating cost. So these are the irrespective of the production of the plant. So if I multiply this with y1 and this with y2, this and so on, I'll be getting the answer for that. Okay, so let me write that. So 2,100,000 into y1 plus 850,000 into y2 plus 18, okay, 100,000 into y3. Be careful with the number of zeros. 1100,000 y4 plus 900,000 y5. So this is the fixed cost. Next, what is the transportation cost? So what is the transportation cost? Simply we have to multiply the total number of items transported with the total number of this to the where we are transporting with this cost, transportation cost. Okay, so in other words, see what are our variables. So our variables are like this. Okay, So here I already defined, right, x4b, something like that. Okay, so let us first write the variables. Yeah. So x1a, that means number of thousands of vehicles going from warehouse 1 to, sorry, plant 1 to warehouse A. Okay. Similarly, x2a, x3a, x4a. I'm sorry, 1a, 1b, 1c, 1d. So just I want to write in this format. So now, next one will be x2a, x2b, x2c, x2d. Similarly, x3a, x3b, x3c, and x3d, and x4a, x4b, x4c, and x4d. Now I want to multiply the coefficients with this. Okay, so directly I have 56, 21, 32, 65. Next row 18, 46, 7, 35. Next row 12, 71, 41, 52. Next row 30, 24, 61, 28. Oh, by the way, one more is there. X5A, X5B, X5C, and X5D. Okay. So here I have 45, 50, 26, and 31. So here I will plus. So all these terms, if I add, okay, so keep on adding this, 5 into 4, 20 terms. So this total is the transportation cost. Okay. So let's call this as a fixed cost and transportation, FC and TC. Okay. So what is the objective? Here you see finally minimize the total cost. Okay. So our formulation will be, I will write the formulation like this. Okay. Minimize total cost, which is equal to FC plus TC. So instead of writing the fixed cost and total cost, all these terms in this page, I'm just writing like this. Okay, so this needs to be minimized. Now let us look at the constraints also. Okay. So what are the constraints? So the constraints are like this. Okay, so the transportation cost and production capacity is given. So let us include the production capacity constraint. Plant 1 cannot produce more than 12,000. Okay, so, and here we should be very careful with the units. Here it is 12,000, but our variables x1a, x1, all these things are already in thousands. So here I simply have to mention 12. Now what is that? X1a, X1b, X1c, X1d. Okay, so these four. Okay, so let me do that. X1a plus X1b plus X1c plus X1d. This is the total production of plant 1. This has to be less than or equal to the production capacity, which is 12,000. So here you just give only 12 because we defined the variable such that they are in 12. They are in thousands. So here is where a lot of students will make a mistake in solving this problem. Okay. So production capacity. So capacity of plant 1. Now capacity of plant 2, capacity of plant 3, capacity of plant 4, capacity of plant 5. Okay. And all of them will have a capacity constraint. Okay. So what I will write here, 2, 1, 2A, 2B, 2C, and all these things. Okay. So to save time, I'll just quickly pause the video and do it. So that's it. So here I have written down all these things, 2A, 2B, 2C, 2D, and so on like this. So these are the capacity, production capacity constraints. Next, what other constraints are there? Again, if you look at this, here annual demand is there. Okay, so we need to meet a demand of 6,000, 14,000, 8,000, and 10,000. So now this one, because it's a demand you have to meet, right? So we'll consider this as the equality constraints. Okay, so let us try like that. In fact, you can meet more than this. You can transport the things more than the demand. But let us right now consider that this is the equality constraints. Okay, so now let us do that. Annual demand of warehouse A. So how do I get the warehouse A values? I have to add vertically. Then I'll get the total items at warehouse A. So, okay, so let me do that. So here I'm writing. So x1A plus x2A plus x3A plus x4A plus x5A. This should be exactly equal to 6,000. So I'll make it as 6. Okay. So this is the demand constraint, demand of A. Similarly, I have demand of B, then demand of C, and demand of D. And here the demands should be equal to 14, sorry, 14,000, 8,000, and 10,000. Okay, so 14, 8, and 10. Okay. So again, let me pause the video and write them. So that's it. So here I have written all the demand constraints also. Okay, so we completed the objective function, then we got the production capacity constraints and the demand constraints. Are there any other constraints? So sometimes they mention, at least two should be operating or something like that, but there looks like there are no other constraints. By the way, this reminds me, what if the plant is not operating? If the plant is not operating, then the capacity equivalent to having capacity of 0. Okay, so here you should be again careful. Here you multiply with y1, y2, y3, y4, and y5. So if you multiply with this, if y1 is 1, then it will be less than or equal to 12. That means this plant will operate. But if one of the plant is not operating, then let's say y2 is 0, then here it will become 0. Therefore, all these variables will become 0. Okay. So finally, one more constraint I have to add, that is xij is integer. So it for all integers, it is for all values of xij, this is integer, because we are only considering uh, manufacturing in terms of not a fractional manufacturing, but in the batches of thousands. Okay, so I think that's it. So this is our entire formulation. Actually, in the place of FC and TC, we should be writing this whole thing. So there is no place. So that's why I have written. Okay, so now let us solve this problem and then find the answer, and then we can see how it goes. Okay, so how to solve it? So I am solving it using Excel. Okay, so this is an empty Excel sheet. So let me start by saving this. So let's call this with the name of the company, that is Terraco Motor Company, or TMC. Okay, so now let's start entering the problem parameters. Okay, so here there are 20 variables. Okay, so we have different ways to organize it, but let's call it like this: x1a, x1 I'm sorry, x1b, x1c, x1d. That's it. Okay. Okay. So now for another set of variables, I'll just copy and paste these things, and then only select this, and we'll try to do find and replace. So let's see. Data, is there a find and replace? Yeah, I tried Control H, and the Control H is nothing but find and replace. So find one and replace with two. I'll say replace. So only in your selection it will do. Okay. Next, again I will paste one more set of variables. So first let me select these columns. So I need to select 20 columns because we have 20 variables. So okay, so I paste it again. So here Control H. So all ones will be replaced by 3 and all twos will be replaced by 4. Then finally last 4 variables. Let's replace 4 with 5. So Control H, replace 4 with 5. Okay, done. So here I have defined the variables. So let me now optimal solution. So this is what optimal solution I have to find out. So I'll mark all these squares and then I'll give yellow color for it. Next, what is the coefficients for this? By the way, I have 5 more variables, right? We have the plants. Okay, so y1, y2, y3, y4, and y5. Which plant to be operating and which plant to be kept closed. So these are the 5 binary variables. So let me also add them here. Slightly different color I will give just to identify that they are binary variables. Whereas these other ones are integer variables. Okay. So now we have the unknowns setup, optimal solution. Next, let's do the coefficients of cost. Okay, so total cost. So this to be minimized. Okay, so I'll say minimize total cost. So what is the coefficients? So in this case, the transportation cost will come into picture. So I have already written the transportation cost here. If you see 56, 21, 32, 65, these are all coefficients of the transportation cost. So this as it is, I will add here so that it will be directly there. So I can just uh, and I can refer to this question also. Directly from this I can enter those values. Okay, so just give me a second, let me pause the video and I will enter. So that's it. So I have entered the coefficients for the variable cost, that is the transportation cost. Now coming to the fixed cost. So here one more thing you need to be really careful about is this X1A is the number of vehicles in thousands. So in other words, here I have written, for example, X4B is 7. That means from plant 4 to warehouse B, we will transport 7,000 vehicles. For that, this X4B, you can see here, this 24 is actually 24,000 is the transportation cost. So all the cost actually is more by 1,000. So, or in other words, if I calculate the cost in thousands, then this fixed cost, what I should do, I will simply remove these 3 zeros. So all remove all last 3 zeros and then I will say total fixed cost in thousands of dollars. Thousands of dollars. Similarly, here total transportation cost also in thousands of dollars. This, if you don't make it correctly, then again your answer will be wrong. Okay, so be careful. Not only that you should know the procedure, but you should also look at the small things where you may do an error. Okay, so here if you see the total cost is FC plus TC, but then the FC, earlier the FC was defined wrongly, but now this is the correct way of defining the FC. So in fact, when you write down this in your notes, you simply remove this zeros, don't even write them, and then say fixed cost in thousands of dollars. So that is how you can write it. Now this is what we are going to enter. 2100, 1800. So let me write here 2100. I think the space is less, so let's make it little bit more. Yeah, 2100, then 1800, 850. Sorry, second is 850, third is 1800, fourth is 1100, and fifth is 900. So these are the transportation costs. So now if I multiply this row with the above row, do a sum product, then I will get the total, the cost. Okay, so what is the total cost which needs to be minimized? Okay, so slightly I'll reduce the magnification. So this is the LHS, left hand side, is equal to sum product, and then select this. First is the select the array of the variables. So here I have to keep dollar before 5 and dollar, so that the multiplication, I can copy this for the other constraints. Now the array 2 will be this one. That's it. So now here the LH is showing 0. This is the cell that we need to minimize. Okay, so that is the cost. So now let us add more constraints. So what are the other constraints? So now look at this thing. So first I have the production capacity constraints. Okay, so this is easy to define. Now here what I want to do is to make it in the standard format. This 12y I get to the left side. Okay, so then it becomes minus 12y and less than or equal to 0. Okay, so in other words, if I write here, I will have x1a plus x1b plus x1c plus x1d minus 12y1 less than or equal to 0 it will become. So basically this first line and the last line is same, just that this term I shifted to left side to become minus 12. So this is the format, standard format in which we are going to write the equations in the Excel. Okay, so let us do that now. So prod capacity constraint, or simply prod capacity at plant 1, production cap at plant 1. So here I will add all the what you call the production of from plant 1 to all 4 warehouses. Okay, and here I'll put minus 12. Okay, so because minus 12 into y1 is the variable, and this will be the LHS. So here I'll copy and paste this, and it should be less than or equal to, and it will be 0. Okay, so here the RHS will be anyway 0. So let's reduce this so that you can see on your screen. Now let us continue. So for production capacity of second plant, here I will take these variables, that is 1 into x2a, 1 into x2b, and so on like that. All these variables will be selected, and here it will be minus 18. So if you see here, 18 y2 is on the right side, so it comes this side to become minus 18. So again, this I can copy this formula here, copy paste, less than or equal to 0. So again I will pause and I will add the these formulas for other 3 plants, that is plant number 3, sorry, plant number 4, and plant number 5. So look at these equations, the same equations I am going to transfer it to the Excel sheet. Okay, so let me pause the video now. So that's it. So we got the production capacity equations defined for all the 5 plants. Next, what is our constraint? The next constraint is demand at A, demand at B, demand at C, and demand at D. And here I need to do vertical addition of the variable. That is x1a, 2a, 3a, 4a, 5a. So this is like this. If I add, I'll get this one. So again, these are equality constraints. So let's write this now. Okay. So one I will show you. So here I have demand A, demand B, demand C, demand D. So there are four warehouses. Now how to select only the production of this one? So here it is one. Then here you see this column. Again A is coming. X1A, X2A. So here I give 1, X3A 1, X4A 1, and X5A 1. So this easily I can again copy, come down, and then just move one step ahead, paste it. Again copy, paste. Again copy, paste. So this is how we can get the productions. And this demand has to be exactly equal. Okay, so at the warehouse. Okay, so equal to, I'm sorry. So here I'll just simply give single quote equal to. So if you want to give equal to symbol in Excel, you have to precede it by single quote. And of course, this I will copy. And this is the production demand. Okay, so here you can see 6, 14, 6, 14, 8, and 10. Okay, so 6, 14, 8, and 10. That's it. So now we have the entire problem formulated. So now this is the RHS. Now let's first I will save this, and now let's go to data and solver. Okay, so I'm opening the solver. Set the objective. So what is our objective? So this one, this minimizing the cost is our objective. So select the minimization. Then by changing the variable cells, what are the variable cells? So all these cells that are marked here, these are the variable cells. Then subject to constraints. So what are the constraints? So add the constraint, that is this one. In fact, I can drag all these 5 values at a time, less than or equal to, and then this side, right side, 5 values at a time. So what are these constraints? Production capacity constraints. Now the demand constraints. So let me add all 4 and then say equal to, and then these are all demand constraints. I'll say add. Next, I have to find that these are binary variables and these are integer variables. So let you now select y1 to y5, and then I will say bin, bin, so binary, add. Similarly, b5 to u5, this 20 blocks, I'm selecting as int or integer and say add. So now let's once again verify. So I defined AB7, that is as our variable to minimize, by changing B5 to Z5. Okay, B5 to Z5, that's also correct. Now what are the constraints? 15 and 18 equality constraint. Okay, so this is correct. 15, 16, 17, 18 equality constraint. Then inequality constraint is row 9 to row 13. Okay, so 9 to 13 less than or equal to. Okay, and all are zeros and this side negative. Okay, and these are binary and integer. Okay, I think looks like we got everything correct. So here solving method, again you select simplex LP and make sure that in the options there is a ignore integer is not there. So simply okay. Now say solve. Just a minute. Looks like this. Where did my answer go? I went to some other sheet. Okay, so this one, data, solver, okay, and now I'll say solve. Solver found a solution. Keep solver solution. I think there is some issue. We are jumping into some other file. So let me close this file. Let me come back to this file, data. So I'll save this file, tmc.xlx. So data solver. Yes, solver found a solution. Say okay. So finally we got the solution like this. Uh, this is 6, 4, 8, then 10 and 10 here. And then all other, y2, y4. So the plant 1 and 3 should be closed. Okay, so that is the final this thing. Let's look at the constraints. So the production capacity, okay. So we are utilizing the full production capacity of one. Oh, I'm sorry. I think okay, correct. We are utilizing the whatever constraint is there according to that of this thing. Production capacity of 5 we are not fully utilizing. That's why -6 is here. That is okay. And the demand is perfectly met. So looks like this is the final solution. So let me write down the solution. What I got. Okay. So like this. So here I will say uh, solution from solver. So simply close down plants 1 and 3 and operate plants 2, 4 and 5. Okay, so this is the first important solution, which plants to close down and which plants to operate. Okay, so that is what this y1, y2, y3, y4, y5 will tell. Next, production. Okay, so or transportation, right? So transport from to number of vehicles in thousands. Okay, so just I'm writing it, with not using the x notation, but like this. So first answer here is 6 to A. Okay, so from 2 to A, 6,000 vehicles should go. From 2 to B, 4,000 vehicles should go. 2 to B, 4. Notice that plant 1 is not operating. Okay. Similarly, from 2 to C, 8,000 units should go. 2 to C, 8,000 units should go. 2 to D, nothing. And 3 is anyway closed. Plant 4, the entire manufacturing of plant 4 should go only to warehouse B. Okay, so 4B, and that is 10,000 vehicles. Okay. Similarly, 4C, 4D all are 0, X all these things are 0. Last one, the entire production of plant 5 should go to warehouse D. Okay, so plant 5 should go to warehouse D, and that is 10. Okay. So total our vehicles are like this, and if you notice we have met the demand. Okay, so what is the total this thing? So 6, 14, 8 and 10. Okay, so looks like this is how much? So this is about 38 is the total demand. So here also you can see 6 plus 4 is 10, 20, 38. Okay, so total 38,000 vehicles demand is met. And what is your minimized cost? Minimized total cost. So minimize the total cost. You see here 3748. Okay, so don't write just 3748. Most importantly, you have to write three more zeros, and then this is your what you call the dollars, or what was this? This is in, yeah, this is in dollars. Okay, so this is the minimized cost. This is the minimized cost. Now imagine if you operated plant 1 also, what happens? If I operated plant 1, then again you can see the plant 1 has a annual fixed operating cost of 2.1 million. Okay, so already here 3.7 million is your cost. It will become 5.8 million cost. Okay, so the cost will increase much more if I operated the plant 1. That is the reason the program is saying don't operate plant 1. And we found the optimal solution. Any other change variation in this may increase the cost. So for example, see, from 2 to A 6 are going and 2 to B 4 are going. So instead of this, if I slightly change, okay, so then what happens? Okay, so if I change something like here 5 and here 5, okay, so 3776. Okay, so 3776. So it is more. Okay, so that way any other solution will be suboptimal. Okay, so like this. So that's why I'm saying undo, and I will save this solution like this. Okay, so this is the answer for this problem. So I hope you like this and you learned something from doing this. So please press like button if you like this video and subscribe to my channel for more videos like this. Thank you.